Hello friends, we have seen knuckle joint design procedure, knuckle joint numerical in previous two videos. Now here today I take you to the new joint, that is turnbuckle. Okay, so as you are seeing the images of turnbuckle, so this turnbuckle is also known as coupler. What? It is also known as coupler. So you can see these images. Please, if you see my cursor, these couplers are made up of two threaded rods. Okay, two threaded rods which are coupled in a frame. See guys, this is a frame. Please see, if you are seeing this coupler, and these external threaded rods are fixed over here with the help of these two hole passes. See, again, if you see in this image, that if you see my cursor, how this coupler is going to be used. See guys, this coupler is going to used to couple two different rods, or to connect two different rods. If you are seeing, so this is one hook of this coupler, which is a threaded rod which is coupled with this frame, and this is another hook which is coupled to that another rod. So see, this is used as a connector in between two threads or two rods, or to any separate members. If we want to join that, then we can use it easily. So all these images, in this image you can see it clearly that how it is helpful to us. That is, this is a hook and this is another side of this coupler, and you can easily see these external threaded rods are fixed into this frame. So now in this video we are going to see how this turnbuckle or how this coupler is to be designed. Okay, what are the various stresses which are going to be acted on this coupler, and what are the various stress analysis, or what are the various factors that we need to consider while designing of this turnbuckle, that we are going to see. So let's begin. Now see what it is written here. So this is design of turnbuckle. You can see design of turnbuckle. So how design of turnbuckle is done? Please see guys, what do you mean by turnbuckle first? That we should see first. A turnbuckle or coupler, as I have told you earlier, that turnbuckle is also called as coupler. See, a turnbuckle or coupler is a mechanical joint which is used to connect two members which are subjected to tensile loading, which require slight adjustment of length or tension under loaded conditions. See guys, I am repeating myself. Please see, please focus on this first point. Turnbuckle or coupler is a what? Is a mechanical joint. Why it is used? Which is used to connect two members which are subjected to tensile loading. See guys, why it is used? It is used to connect two members which are subjected to tensile loading, which require slight adjustment of length or tension under loaded conditions. So see guys, coupler is used to connect two members which are subjected to tensile loads. Okay, so tensile load is going to be act on your turnbuckle. So that is the thing that this has been get to know by us, or this has been cleared by us. Turnbuckle designed to handle tensile loading. Okay, the next point what tells us, please see, it consists of central hexagonal nut called coupler. See guys, it consists of central hexagonal nut called coupler. So that it consists of central hexagonal nut. I want to show you this frame that earlier I have told you about this frame. So this is hexagonal one frame, and this is called as coupler. Okay, this hexagonal frame is called as coupler. Then next is, it consists of central hexagonal nut called coupler and tie rod having right hand and left hand threads. See guys, it again consists of two tie rods that having right hand and left hand threads. As we have seen in this image, you can see that this R is written over here. Please see this R. Okay, this R, if you see my cursor, this R is written over here. So these are right handed threads and these are left handed threads. So these are two tie rods, or we can say it threaded rods. Then a coupler of hexagonal shape is to facilitate the turning of it with a spanner, or sometimes a hole is provided in the nut so that tommy bar can be inserted for rotating it. Okay, as coupler rotate, the tie rods are either pulled together or push apart depending upon the direction of the rotation. Okay, see guys, what tells this point is, please see, as coupler rotate, the tie rods are either pulled together. Okay, the tie rods are either pulled together or push apart depending upon the direction of the rotation. If you rotate that coupler, it means if you rotate that hexagonal nut which is called as coupler, then your tie rod got pulled, means it got move outside of that frame or inside of that frame, and that is depend upon the direction of rotation of that coupler. Okay, this is about the turnbuckle. So by this slide we can easily see that why turnbuckle is used. The turnbuckle is used to connect two members which are subjected to tensile loading, and the central hexagonal nut frame, that is called as coupler, and it consists of two tie rods having right hand and left handed threads that we have seen in figure diagram. Now how it operates: if you rotate the coupler, then tie rods are either pulled together or pushed apart, and that is depend upon the direction of the rotation. So all these things we are get to know by that coupler, by the diagram, and by this slide. So what next? Please see. Then here you can see applications. Now this is the most important part of turnbuckle, that what are the applications of turnbuckle and what is the use of turnbuckle. Please see. The first point is to tighten the members of the roof truss. See guys, to tighten the members of the roof truss. So let me tell you, all of you have seen the roof trusses. Like roof trusses are usually you get to see on the workshops. Okay, workshops roofs and all. So or industries roofs or some shade, if you opening some kind of working area or workshop like, so at that place you can easily get to see this roof trusses, and that roof trusses are connected by using this coupler, used to connect link in a mechanism to transfer motion. See guys, it is also used to connect link in a mechanism to transfer motion, used between the two railway wagons or bogies. See guys, this is the most important and most favorable application of turnbuckle, that it has been used this purpose popularly. It is used between the two railway wagons. See guys, two railway wagons or bogies. As we know, the railways consist of various bogies or various different sections. So that sections we call bogies or wagons, and there is one engine, and to that engine we are connecting so many bogies or wagons. So that connection between one bogie to another is connected with the help of this turnbuckle or coupler. So this is one of the biggest or major application of turnbuckle. The next is to tighten the cable or stay ropes of electric distribution poles. See guys, to tighten the cable or stay ropes of electric distribution poles. So in electric distribution poles, we know that we need to distribute the electricity at so many different places from one storage place. Okay, suppose LDP, load dispatch center is there, LDC, and from that LDC the living area or the area at which you need to provide the electricity is I think it is very long from that area. It is large distance. So at that time you need to transfer your electricity poles and cables and all to that particular place. So in that case, turnbuckle is very important application, that it is used to tighten the cable and stay ropes of that electric distribution poles. Okay, so these are the important applications of turnbuckle, and I think this will be helpful for you. Now see, in this image you can see the design of turnbuckle or the diagram of turnbuckle, which we have seen the image actually original, and after that this diagram is more tells us about the design parameters or design consideration of turnbuckle, that how we need to design the turnbuckle and what are the various dimensions of turnbuckle. That about the dimensions of turnbuckle, this diagram speaks more and more. Okay, please see, if you see my cursor. So see guys, these are two external threaded rods that we have seen in diagram previously. Okay, these are this thread as right-handed thread, and this thread and this rod as left-handed thread. As you see guys, here it is written here. This rod that is right-handed threaded, and this is rod which has left-handed threaded. The next is this P, this symbol P. Please see this. If you see this symbol P and this symbol P, as similarly that you have seen in previous video for knuckle joint, this P is also this P represented to tensile loading of turnbuckle. So this P denotes that your turnbuckle is subjected to tensile load, because the nature of the load which is going to act on it is a pull in nature. Okay, you can see easily. Then after that, this D, this small d, this is the, you can see this is the diameter of threaded rod. Please see this dimension, this D, small d represents the diameter of the threaded rod. This is D1, that is internal diameter of coupler, and this is external diameter. D2 is the external diameter of coupler. Why coupler? Because see, here it is known as coupler. You can see here. Here it is clearly mentioned, this part of the your turnbuckle is known as coupler. Okay, and so internal and outer. This T, now see this T is what? This is coupler nut, and T is what? Thickness of coupler nut or thickness of coupler, you can say. This L also represents the length of your coupler nut. So all these are the notations, or all these are the notations of turnbuckle that are very very much important while designing up this joint. Okay, so here you can see, and this is the cross-sectional area view of turnbuckle, and which thickness is tells us that it is d by 2. So let us see how it is designed, and how the notations, what it stands for, and what is the meaning and all that we are going to see in next slide. Please see. Now these are the notations. Now see, design of turnbuckle. These are the notations of turnbuckle that we have seen in the diagram. Please see. So P stands for design load. Okay, P stands for what? Design load, which is 1.3 or 1.4 times load carried by the rods. Please see, guys. Please see. Please pay your special attention over here. P is what? This is design load, and which is equals to 1.3 times or 1.4 times load carried by the rods. Okay, that we need to take. Then tau, this symbol is for tau. So tau is equals to what? Tau is equals to permissible shear stress in Newton per mm square. It is what? Permissible or allowable shear stress in Newton per mm square. The sigma c, this symbol is called as sigma c. So sigma c means permissible crushing stress in Newton per mm square. Then DO, this DO stands for nominal diameter of rod in mm. See guys, DO means nominal diameter of rod in mm. This L means what? L is equals to length of coupler nut in mm. See guys, this L we have seen in diagram. So length stands for length of coupler nut in mm. Then sigma T. Now what do you mean by sigma T is equals to permissible tensile stress in Newton per mm square. See guys, sigma T is a permissible tensile stress in Newton per mm square. Now the DC means core diameter of the rod in mm. See guys, DC stands for core diameter. Core means internal diameter. Let me tell you, core stands for internal. DC is equals to core diameter of rod in mm. P is equals to what? P is equals to pitch of the thread in mm. See guys, P is equals to pitch of the thread in mm. N stands for, N is equals to number of threads. This is number of threads. And capital D stands for diameter of the coupler nut. See guys, capital D stands for what? Diameter of the coupler nut. So all these are the various notations that we need to calculate the various design parameters or various induced stresses for analyzing the design of turnbuckle, whether it is safe or not. Okay, so all these parameters play very very important role in designing of turnbuckle. What next? Please see. Now these are some assumptions, or these are some assumptions that we need to take in consideration while designing a turnbuckle. Now what are they? Please see. It is an adjustable screw joint used to connect two round tie rods. See guys, what it is actually, what we are doing, or what we are going to design. We are going to design a turnbuckle or coupler. So what do you mean by coupler is? It is an adjustable screw joint used to connect two round tie rods. Okay, it is an adjustable screw joint. We have seen in the diagram, and we have seen in the application. So what it is, why it is used? It is used to connect two round tie rods. Tie rods means threaded rods. Okay, it is used to connect that two tie rods. Then it is used to connect two threaded rods which are under action of tensile load. That is also we know why it is used. It is used to connect two threaded rods that are under action of tensile load, that we have seen. One of the thread has right hand threads and other has left hand threads. That also I have told you earlier, that one of its tie rod has right handed thread and other has left handed threads. The next is the rods are screwed to a coupler which has a threaded hole. See guys, the rods are screwed to a coupler. Whatever the thread rods that we are going to say usually to it, that is tie rods, that are what? That are screwed. Okay, that are screwed means that are inserted, because both that coupler has internal threaded holes, and your rods or tie rods has external threaded rods. So it can easily get screwed to that coupler, so that the required fit is easy to be obtained. So all these are the assumptions, or all these are the what we say parameters of turnbuckle that we need to take in consideration while designing, because until and unless we should know this, because if we are not knowing this, then we can't design the turnbuckle. For that we need to know all the parameters or all the constructional details of the turnbuckle, so that we can design it completely or specifically or perfectly. Okay, now see, so here by that slide we can start the design of turnbuckle. Now let us see what it is. First you are telling, please pay your attention guys, please focus on this design procedure, because if you once understand this design procedure, then it is very easy to solve the numerical based on this turnbuckle, because whatever the formulas and all steps, all sequence that we are following in this design procedure, same sequence, same design procedure, same formulas you need to follow while solving the numerical. Only difference is that in numerical you need to put values in the numerical formula and calculate the answers. Rest of the sequence, rest of the formulas remains same. That is why I am repeatedly told you that this design procedure is very important. Okay, if you once understand this, then you can solve number of problems on the basis of one or on the basis of single design procedure. That is why it is very important to understand. Now please see. Now I am starting with the design procedure of turnbuckle. Please see. So what? Let P is design load, and we have seen this design load is 1.3 times to the load carried by the rods. Whatever the load is given, that we need to multiply it by 1.3 or 1.4. Okay, we have seen it earlier. Okay, in notations slide. Then tau, this is what tau. What tau denotes? Tau denotes permissible shear stress or allowable shear stress. Sigma t. What sigma t denotes? Sigma t denotes permissible tensile stress or allowable tensile stress. This is what sigma c. What sigma c denotes? Permissible crushing stress or allowable crushing stress. Now we need to check all this. So see, what is the first step of turnbuckle, designing of turnbuckle or coupler? As we know, the coupler is used to connect two rods which are subject to tensile load. Okay, so see, what is step number 1? The failure of rod in tension. See guys, what? The failure of rod in tension. This is the first step of designing the turnbuckle. The rod comes under tensile failure. So see what it is. The rod may fail due to tensile load P, and we know that the area that resisting tearing is equals to pi by 4 into DC square. See guys, this is DC, means core diameter. This is DC, means core diameter. Now why it is pi by 4 DC square? Because rod has a circular section. Okay, rod has a circular section, and we are writing the formula for area resisting tearing, means area. So area of circle is pi by 4 into D square into diameter square. So here diameter we have taken DC, that is core diameter of your rod. So we are checking the rod for tensile failure. So that is why we have written the area resisting tearing is equals to pi by 4 into DC square. After that what we have done, see guys, here we have equate this relation with your load P and with your tensile load sigma T, because tensile load is going to act on your rod. So that is why we have equate with this load and this sigma T. So what we have written here, tearing strength of rods is equals to P is equals to pi by 4 into DC square into sigma T. Okay, P is equals to pi by 4 into DC square into sigma T, sorry, not C, sigma T, that is tensile load, sigma T. So by this relation, see guys, by this relation we can easily find out the value for DC, because we have the value, because we have all these values, that is P we have, again sigma T also given in the numerical, or you need to select it from design data book. Okay, then by this relation we can easily find out the value for this DC. So here I have written there, hence value of DC can be determined. Okay, hence value of DC can be easily determined. Now what it is written here, very important statement is written here. Please see, please pay your special attention over here. From the standard table, value of nominal diameter DO and pitch can be determined. After determining the value of DC, please see guys, after determining the value of DC from the standard table, what is the standard table and how we can find the value for DC, that we are going to see in the numerical video, don't worry. So the details about the standard table and how we can find out the value of DO from this value of DC, we are going to see in numerical. But here in this design procedure, you need to take in consideration that you need to know that once you found out the value of DC, then value of nominal diameter, that is DO, and pitch P can be determined easily. Okay, and how that we are going to see in numerical video. Okay, so in this step 1 we have calculated the value of DC. Then after, what is next? Now this is step number 2. Now see what it is written in step number 2. Considering the shear failure of the threads at their roots. See guys, considering the shear failure of the threads at their roots. So their shear force is acting on your threaded rod. So that is why we have considered the shear failure of threads. Okay, at their roots. Okay. So area resisting shear. What is the area of resisting shear? Is equals to, it is given by this relation, pi into DC into L. See, pi into DC into L. So we have to check the shear stress acted at the thread roots. For that we need to equate it with the P, that is design load. So P is equals to pi into DC into L into tau. This is not T. This is not T. Let me tell you, this is a symbol, that is tau. So by this relation we can easily find out the value of, hence the value of L can be determined. This value of L, that is length of coupler nut, and L stands for length of coupler nut. So by this equation or by this relation we can easily find out the value of L, because value of P is given to us, value of tau is given to us, value of DC we have determined in first step. So we can easily determine the value of this L. Okay, hence the value of L can be determined. L stands for length of coupler nut. Okay, but what it is written here, please see. But in actual practice, length of coupler nut L can be taken as DO is equals to 1.25 times DO for steel, and DO is equals to 1.5 times DO to 2 times DO for cast iron. See guys, once you have calculated the value for L, okay, once you have calculated the value of L, so what we need to check, or what we need to change in this finded value, we need to change some standard empirical relations, because length of coupler nut we need to take on as DO is equals to 1.25 times DO because of some reason for steel material, and for cast iron materials that we need to take DO is equals to 1.5 DO to 2 DO for cast iron. So this, all these factors or all these assumptions we are going to clear in numerical video, don't worry. Okay, so this is step number 2. In this step we have calculated the length of coupler nut, and that we need to change the dimension according to this standard empirical relation for steel and cast iron, and how and why it is done, that we are going to see in design numerical video. Okay, so this is step number 3. Now what it is written in step number 3? Step number 3 is here checking the crushing stress induced in the threads. See, crushing, now your threads are also subjected to crushing stress, so we need to check it for crushing stress also. So induced crushing stress should not exceed permissible crushing stress. This condition is applicable to each and every step. Okay, it is, I have mentioned only here, so it doesn't merely means that this statement is applicable only for this step. Okay, this sentence, that is induced stress should not be exceed to permissible stress, this statement is acting for each and every step or each and every component that you are designing. Okay, your induced stress should not be goes beyond or should not be exceed to the permissible or allowable stresses. So here it is written clearly, induced crushing stress should not exceed permissible crushing stress. Now what it is written here, see, area resisting crushing of fork end. See what it is written, area resisting crushing of fork end, that is pi by 4 into DO square minus DC square into N into L. So we need to equate this relation with the load, design load P. That is why we have written here P is equals to pi by 4 into DO square minus DC square into N into L into sigma C. So here we have again added sigma C, because we need to check that induced crushing stress should not exceed over permissible crushing stress. Okay, so here we have written where N is equals to what, number of threads per mm length. Okay, N is equals to what, N is equals to number of threads per mm of length, and N value is given, N is equals to 1 divided by pitch. See guys, it is given 1 divided by pitch. The value of N is given, that is 1 divided by pitch. So here we have written, so by this we can easily find out the value for sigma C. Okay, value for sigma C. So sigma C is equals to P divided by pi by 4 into DO square minus DC square into N into L. Okay, pi by 4 into DO square minus dc square into n into L. So by this relation we can easily find out the value of this sigma c, that is induced sigma c. Let me clear you, whatever this sigma c we have calculated, okay, by this relation we have calculated this sigma c. So this sigma c denotes induced crushing stress. Please let me tell you, and your value of induced crushing stress should not exceed to value of permissible crushing stress. So it means whatever will be the value which is given in the problem, or whatever will be the value that you have selected from the design data book, that value should not be less than this value. Okay, that means induced crushing stress should be less than your permissible or allowable crushing stress. Then and then only it means that your design is safe. So I think you have understood this. Now this is step number 4. What is step number 4? Considering the tensile failure of coupler nut. See guys, step number 4 is your considering the tensile failure of coupler nut. Now coupler nut all of we have seen in diagram. So design diameter, consider diameter capital D of coupler nut is found by considering tensile failure. See guys, we are considering this diameter of coupler nut D can be find out by considering tensile failure of that coupler nut. See guys, that is why we have written here sigma T is equals to P divided by pi by 4 into D square minus DO square. So we have all these values, sigma T we have P, DO, so we can easily find out this value of D. Okay, in this, by this step we can easily find out the value for a diameter of coupler nut. Next is here considering the tensile failure of coupler. See guys, considering the tensile failure of coupler. So now we need to consider the tensile failure of coupler. So what it is, outer diameter D2 of coupler is found by considering tensile failure of coupler. See guys, we have calculated the value for D, that is diameter of coupler nut we have calculated tensile by considering the tensile failure of coupler nut, and here we need to find out the outer diameter of coupler by considering the tensile failure of coupler. Okay, so don't worry, how we can find out outer diameter D2 of coupler is found by considering tensile failure of coupler. Okay, so tensile failure of coupler we need to write again sigma T is equals to P divided by pi by 4 D2 square minus D1 square. This is not 12. Okay, this is not 12. Let me tell you, please see, I focus your attention over here. This is D1 square. I think this is some typing mistake. So this is D1, this D and this one is D1 and this is square. Okay, don't get confused over here. This is D2 square and this is D1 square. So where inside diameter of coupler is equals to D1 is equals to DO plus 6 to 8 mm, that we need to change. D1 is equals to what? DO plus 6 to 8 mm. In practice, the outside diameter of coupler is taken as 1.5 DO to 1.7 DO. So we after calculating the value of D2, so we need to change it to 1.5 times DO or 1.7 times DO because some reason. And length of coupler is equals to 6 times DO, and thickness of coupler is equals to T is equals to 0.75 times DO. So all these empirical relations we can use after finding the value of this DO or D2 whatever. Okay, so these are some steps of design steps of turnbuckle. So let me revise one more time. So here is the design procedures for turnbuckle. Step number 1 is failure of rod under tension. By this we can calculate the value of DC. Once we have calculated the value of DC, that is core diameter, then we can easily find out the value for nominal diameter DO and pitch of that threads, okay, by the standard table. Okay, the next step is here considering the shear failure of threads in their roots. So for that we need to equate this relation pi into DC into L with the design load P and tau. So by this relation we can easily find out the length of coupler nut L. Okay, and this length of coupler nut we need to taken as DO is equals to 1.25 DO for steel, and DO is equals to 1.5 times DO to 2 times DO for cast iron. Then next is checking the crushing stress induced in the threads. Okay, step number 3 is here we need to check the crushing stress induced in the threads, and for that we have written this equation, and we need to check this sigma C, and the value of this sigma C should be less than your allowable or permissible crushing stress. Then next, considering the tensile failure of coupler nut. See guys, after that we need to consider the tensile failure of coupler nut. So we need to find out the tensile failure of coupler nut by considering the coupler nut under tensile failure. So sigma t is equals to p divided by pi by 4 into d square into d square minus capital D square minus do square. By this relation we can easily find out the value of this d. And this is the last step of designing turnbuckle, that is considering the tensile failure of coupler d2. So how we can calculate the value of d2? By considering the coupler under tensile failure. So we have written this formula, sigma t is equals to p divided by pi by 4 into d2 square minus d1 square. So I have repeatedly told you, all my viewers, please don't get confused over here. This is d1 square. Okay, this is mistakenly typed there d12, that this is not d12, this is d1, and this is 2 for square, d2 square minus d1 square. So once we have calculated this, so all these changes we need to make in these calculated values for safe design. So here by this slide we have completed the design procedure of turnbuckle.